All right, this is the second video for section 13.3. This is the main part of this section. So you should have copied all this stuff down. So what we're looking at, we always take a trig function of an angle to equal a ratio for a right triangle. Now, we're talking about any angle measurements now, not just in a right triangle, but any angle measurement. So we should be able to figure out what's the sine of 150 degrees or the tangent of negative 275 degrees. And so how we do it is by putting those angles onto the xy axis. So the original angle is, looking up at this picture here in the upper right corner, the original angle is this theta. But what we're going to do is use the reference angle here in green. Okay, that's going to be our reference. And so now, wherever this point is, this point P, x comma y, that coordinate, what you're going to do is drop a perpendicular to the x-axis. So no matter where that point P is, always draw your perpendicular to the x-axis, and there's forming the right triangle. And so now, if we look at this green angle, you take the sine of that green angle, I'll call it phi or psi, I forget which letter that is. It's a Greek letter. The sine ratio for this right triangle is always opposite over hypotenuse. So that's y over r. Cosine of that angle would equal x over r. Tangent of that angle would equal y over x. All right? And then your other trig functions, cosecant, secant, and cotangent, same idea. So this is the main thing. Now we can figure out the value of these, the trig function of these any angle measurements just by plotting a point and drawing that perpendicular to the x-axis. So now, a couple little details. This value of r is always positive, greater than 0. Okay. Other little details. Main thing here is, and I'll talk about it in one of the examples, but you really just got to pay attention to where this point is. You know, looking at where point P is in this picture, we got negative x coordinates just because of where the point is and a positive y coordinate. Now, with r always being positive, you take the cosine of that angle, x is negative. That means we're going to be getting a negative answer for the cosine of this angle. A negative x value divided by a positive r value is a negative answer. And so it kind of creates a lot of little things to think about. So let's do an example. All right, it says find the exact value of the 6 trigonometric functions of theta given each point on the terminal side of theta in standard position. So let's just do number 13 right now. So we have this point, 3, negative 4. Want to figure out what is all these trig functions of the angle formed where that point is on the terminal side. So I'm just going to plot the point, 3, negative 4. Here is our point P. All right, what we're going to do, this point is on the terminal side. And so what we have is an angle measurement. Now, did the problem say, it doesn't say anything about theta being positive or negative. It really doesn't matter. The only reason I'm asking about it is because I just wanted to draw this. This is really our angle theta. Starting at the positive x-axis, 0 degrees, we rotate it counterclockwise to the terminal side of the angle. But we are not going to use that angle. What we're going to do is draw that perpendicular to the x-axis and use the reference angle. Okay, the angle between the terminal side and the closest part of the x-axis. Now we've got a right triangle. We know a couple of things about it. We know the x-coordinate is 3, or at least that side length is 3 because of the point. We know this side length, the side length of the triangle is 4, but we are going in the negative direction. So I'm going to throw that 4 on there. Now, you do Pythagorean Theorem, you're going to find that hypotenuse to be 5. And again, we are using the reference angle. But, let me get rid of this. We can still just call this theta. We are going to get the same answers, even though we're looking at a different angle measurement, not a 300-degree angle, we're looking at a negative 60-degree angle or something like that, we're getting the same results because we're still dealing with the same right triangle for this point. So, all the trig functions of this angle. Now that we know all three sides, it's just a matter of doing the ratios. With theta as our reference angle, sine, negative 4/5. Cosine of theta, positive 3/5. Tangent theta is the opposite over adjacent, so negative 4/3. All right, once you've got the three main ones, the other ones, they're just the reciprocals. Secant of theta is the reciprocal of cosine, so 5/3. Cosecant of theta is the reciprocal of sine, so 5 over negative 4, and cotangent, of course, is the reciprocal of tangent, so a negative 3/4. There's all 6 trig functions for this angle measurement. Again, we used our reference angle, but the actual angle was that one. Okay, but we used our reference angle, we're going to get all this exact same answers. The last problem says, given the quadrant of theta in standard position and a trigonometric function value of theta, find the exact values for the indicated functions. All right, so again, let's just do the first example. So, our angle is going to be in quadrant 2. We know the sine of that angle is 4/7. The question is, what is the cosine? All right, so I'm just going to draw the picture here. We are dealing with quadrant 2. So that is somewhere here. I'm just going to draw a generic picture. All right, this is my angle theta. Where quadrant 1 starts here, then you go counterclockwise. So quadrant 2 is over on this side. Now, we're going to draw that perpendicular to the x-axis. This becomes our reference angle. It says the sine of this angle is 4/7. So from our reference angle, sine is opposite over hypotenuse. Okay, the question is, what is the theta value, or sorry, cosine of theta? So that means we need to know that x value. Well, Pythagorean Theorem, it's a right triangle. So 4 squared plus x squared equals 7 squared. X squared equals 49 minus 16, which is 33. Square root of that. All right, just leave it in exact answers. Plus it says find exact values. So x is the square root of 33. But here's where you really got to be paying attention for every single problem. You're dealing with coordinates, okay? X and Y coordinate system. Look at where our point is. We are going in the negative x direction. So this side length here is really a negative square root 33. You got to pay attention to where you are in the coordinate grid system to determine positive or negative values. And so now the cosine of theta, adjacent over hypotenuse. There's our cosine theta. And we can get all the other trig functions now if we wanted to, because we know all three sides of that triangle. And so that's the gist of this section. We'll do a couple examples in class. Have a good night.